Hello and welcome to my science tutorials. In today's video, we want to look at dimensional analysis WAEC physics past questions and answers. Before we begin, if you're new to the channel, make sure you subscribe to the channel and turn on the notification button so that you do not miss any of our latest video. So without further ado, let's begin. So we have example number 1. This is the SSCE 1999 question number 5. So which of the following dimensions is for kinetic energy? So the question is demanding we find a dimension for kinetic energy. So let's look at the solution to this problem. Solution. So kinetic energy is the energy possessed by a body by virtue of its motion. So it is given mathematically as half mv squared. So this is equal to, we still maintain our half. Okay, now the m is for mass, so we write mass, okay, multiplied by velocity square, multiplied by velocity square. Now velocity is distance over time. Okay, so distance over time is the velocity, so I now square it. So this is just the same as me writing mv squared. So I now bring my half here, then I put the dimension sign over here, so kinetic energy, okay, then I put it in this bracket, means the dimension of it. So this means the dimension of mass times distance over time. Okay, but the distance over time should be squared, the dimension of that squared. So this is equal to, so from here kinetic energy will be equal to half the mass, the dimension for mass will be m, just m, then multiplied by the dimension of distance, okay, is l, so we write l here. The dimension of time is t, so we put it like this because distance is measured in length, so the dimension is l, so we square it. So from here we have half m multiplied by, here will become l squared on t squared. Now if we bring t to the top, we'll have half multiplied by m, we have our l squared already here. When we send the time squared to the top, it becomes t minus 2. Okay, so ignoring the coefficient, the dimension for kinetic energy will be ml squared t negative square, and that means that our option A over here is the correct answer. So let's have a look at another example. Example number 2, we have to find the dimension of momentum, or the question is saying the dimensions of momentum are, this is SSCE 2002 question number 3. So let's look at the dimension for momentum. So solution. So momentum let me remove the dimension sign for now. Momentum is given mathematically as the product of mass and velocity. And so if we apply the dimension symbol, so it means the dimension of momentum will be equal to the dimension of mass multiplied by the dimension of velocity, okay, which in this case will be what? Distance on time. So this will be equal to, the dimension of mass is m multiplied by the dimension of distance is l divided by the dimension of time is t. So this will be equal to m multiplied by l. The t, if we bring it to the top, it becomes t raised to the power negative 1. The dimension over here for momentum will be m lt minus 1. And if we look through the possible answers, option C is the correct answer. So therefore the dimension of momentum is mlt raised to the power negative 1. All right, let's have a look at another example. Example number 3. It said, which of the following is a derived unit of work? This is the WASSCE 2007 question number 1. Right, so let's have a look at how we can use dimension or dimensional analysis to find the unit of work. So let's write down our solution. So work can be defined as the product of force multiplied by distance. So if you move an object with a particular force over some distance, the product of the force and the distance becomes the work. Now, let me break this down. This can be equal to, so work represented by W will be equal to, the force is equal to mass multiplied by acceleration. We use acceleration here, acceleration, then multiplied by distance. Now, take note that the acceleration over here and the mass gives you the force over here. So this is equal to, so the dimension of work will be equal to the dimension of mass multiplied by the dimension of acceleration due to gravity. So acceleration multiplied by the dimension for distance. Now, mass will give me m. Acceleration, okay, that will be velocity square. Sorry, acceleration is velocity over time, right? The rate of change in velocity. So that will be velocity over time. Okay, so let me still put this over here. Multiplied by distance. The distance is L. That's the dimension of distance. So if you look at it, velocity, okay, as we saw in the previous example, velocity is distance over time. So the distance is measured in L and then the time is in T. So the dimension for velocity is LT minus 1. So if you look at that, or we use that in place of the V over here, we'll have mass here multiplied by, then here the top will become LT minus 1 over T multiplied by L again. So from here, let me continue down here. I have M multiplied by here, the LT minus 1 over T. If we send the T to the top, it also becomes minus 1. So we'll have LT minus 2, then multiplied by L. So from here, we know that the dimension for work will be equal to M. The L will multiply each other. We'll have L squared, and then T minus squared. Okay, so this is the dimension. But how do we derive the unit from this? So we know that the M stands for mass, okay? And mass is measured in what? Kilograms. So we have kilograms over here. We know L stands for distance, okay? Now the distance is measured in meters. So we have meters squared. And then we have T over here. T, which is time, is measured in seconds. So we have seconds raised to the power minus 2. So this becomes the unit for work. Okay, so from here, if we look through the possible answers, we can see that option D is kilogram meter square per second square. Okay, so that becomes the correct answer for this particular example. So thank you so much for watching. This is how we use dimensional analysis to solve how to derive the unit of a particular work. And these are some few examples of practical questions that came in WAEC. So thank you once again for watching, and I'll see you in the next video. Bye bye.